A Carnegie Institution for Science audio press release for March 18, 2014. Mercury's contraction much greater than thought. New global imaging and topographic data from the Messenger space probe show that the innermost planet has contracted far more than previously estimated. The results are based on a global study of more than 5,900 geological landforms, such as curving cliff-like scarps and wrinkle ridges, that have resulted from the planet's contraction as Mercury cooled. The findings, published online March 16, 2014 in the journal Nature Geoscience, are key to understanding the planet's thermal, tectonic, and volcanic history and the structure of its unusually large metallic core. Unlike Earth, with its numerous tectonic plates, Mercury has a single rigid top rocky layer. Prior to the Messenger mission, only about 45% of Mercury's surface had been imaged by a spacecraft. Old estimates, based on this non-global coverage, suggested that the planet had contracted radially by about 1/2 to 2 miles, or 0.8 to 3 kilometers. This is substantially less than indicated by models of the planet's thermal history. Those models predicted a radial contraction of about 3 to 6 miles, or 5 to 10 kilometers, starting from the late heavy bombardment of the solar system, which ended about 3.8 billion years ago. The new results, which are based on the first comprehensive survey of the planet's surface, show that Mercury contracted radially by as much as 4.4 miles, or 7 kilometers, substantially more than the old estimates, but in agreement with the thermal models. Mercury's modern radius is 1,516 miles, or 2,440 kilometers. Lead author of the study, Paul Byrne, is a planetary geologist and Messenger visiting investigator at Carnegie's Department of Terrestrial Magnetism. He says that these new results resolve a decades-old paradox between thermal history models and estimates of Mercury's contraction. Now the history of heat production and loss and global contraction are consistent. Interestingly, these findings are also reminiscent of now obsolete models for how large-scale geological deformation occurred on Earth when the scientific community thought that the Earth only had one tectonic plate. Those models were developed to explain mountain building and tectonic activity in the 19th century before plate tectonics theory. Byrne and his co-authors identified a much greater number and variety of geological structures on the planet than had been recognized in previous research. They identified 5,934 ridges and scarps attributed to global contraction, which range from 5 to 560 miles or 9 to 900 kilometers in length. The researchers used two complementary techniques to estimate the contraction from their global survey of structures. Although the two estimates of radius change differed by 0.6 to 1 mile, or 1 to 1.6 kilometers, both were substantially greater than old estimates. Sean Solomon is principal investigator of the mission, former director of Carnegie's Department of Terrestrial Magnetism, and current director of the Lamont Doherty Earth Observatory at Columbia University. He became interested in the thermal evolution of Mercury's interior when the Mariner 10 spacecraft sent back images of the planet's great scarps in 1974 and 1975. The thermal history models predicted much more global contraction than the geologists inferred from the scarps then observed, even correcting for the fact that Mariner 10 imaged less than half of Mercury's surface. This discrepancy between theory and observation, a major puzzle for 4 decades, has finally been resolved. Solomon states it's wonderfully affirming to see that our theoretical understanding is at last matched by geological evidence. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.